Alright guys, welcome back. So today we're taking a look at the half angle identities now. So reversing what we did with the double angles. So the half angles are a little interesting. Sine theta over 2 and cosine theta over 2 you can see are both involved with a plus or minus and then a square root expression using cosine theta. So for both those, we're pretty much no matter what's given, we want to find what cosine single theta is to apply the formula. The plus or minus, this is going to tell us we actually do need to care about where the half angle quadrant was. So the double angle quadrant from the previous video, we didn't care because it was two different quadrants, so sometimes it was one quadrant positive, one quadrant negative, so it was kind of irrelevant. Here, the half angle quadrant will be half of an entire quadrant, so it is relevant to know where exactly we are operating in. If we're operating, for example, in quadrant 2, the cosine theta over 2 would need the negative square root, whereas the sine theta over 2 would need the positive square roots. And again, this is the half angle quadrant, not the original angle quadrant. As for tangents, the main formula is also again based on the plus or minus square roots, but there are some alternative formulas you can work with. This one right here is my favorite to use. If I had to pick one at least, simply because since the denominator is a single trig function, just sine, not add extracting with anything else, when inevitably sine theta is a radical or a fraction, but more importantly a radical, then it's easier to deal with rationalizing when it's a monomial term like that one, rather than the 1 plus cosine theta expression. If cosine's a radical, then you got a conjugate expression to deal with instead. It's essentially the same thing, really, just a small little difference, just I prefer that. Alright, so we got sine theta over 2. We're told sine single theta is negative 5/13, and theta is in 3 pi over 2 to 2 pi. So theta is in quadrant 4. So finding cosine theta is necessary to solve the problem here. So again, given sine, as you've seen numerous times before, cosine is 1 minus sine squared. We get a 25 over 169. So the 1 is 169 over 169, giving us 144 over 169. Squaring that gives us cosine single theta to be 12/13. And in quadrant 4, it's a positive 12/13. Again, very important to make sure you are aware of which quadrant you want to be in for single theta. Now, for the half angle quadrant, for whether or not I'm using the plus or minus, I do have to cut all the angles in half. So that gets me 3 pi over 4 to theta over 2 to pi. So we are in half of quadrant 2. And in quadrant 2, the sine theta over 2 formula is going to be a positive one. So we're going to say sine theta over 2 is the positive square root of 1 minus our cosine value, all divided by 2. So we're doing 1 minus, so that 1 is really 13 over 13. So we get a square root of 1/13, and instead of dividing by 2, we multiply by a half, so it's times a half there. So we get the square root of 1 over 26, which we will separate out as square root of 1 over square root of 26, which then requires us to rationalize. And we get root 26 over 26 for our sine theta over 2 value. Again, sine single theta was negative because single theta was in quadrant 4, and for the half angles, it's necessary to cut the original quadrant information in half to find the theta over 2 quadrant. So that's what we're cutting in half, recognizing this exists in quadrant 2. And then quadrant 2, sine is positive, so we chose the positive square root expression. All right. So for cosine theta 1 here, so this time, so we're given cosine theta to begin with, and there's a reason behind why I gave it for this one right here. If you look at the problem, you're going to notice that it's a radical there, but we're plugging into a radical expression. Now, whether it's a positive or negative radical expression, well, we go and divide it in half. And 450 and 540 are not part of the unit circle, so normally you'd want to subtract first, but that's not the case. We always want to divide first to get to where the half angle quadrant is. If that half angle quadrant is still greater than 360, then we would subtract by 360 to find the equivalent quadrant. But the actual theta value has to be cut in half first. So we can see theta over 2 is operating in half of quadrant 3, where cosine theta would be negative, so we're going to use the negative squared formula. So we have our negative square root, we have our 1 plus cosine theta, so it's 1 plus the negative root 10 over 4, all divided by 2. Now, unlike the previous one, we're not going to be able to actually combine the 1 and that negative root 10 over 4, but we can rewrite the 1 as 4 over 4, and then get a common denominator. So that's our common denominator. We can combine them to a single fraction, 4 minus root 10 over 4. And again, rather than dividing by 2, we multiply by a half. I can't reduce because there's no 4 or whatever in front of the root 10, so I can just multiply across. I get negative square root of 4 minus root 10 over 8, which I can then separate out. Square root of 8 is 2 root 2. So we have to rationalize. Now, rationalizing, you have to be very careful with this expression that's going on right here. The bottom is going to be a 4, because root 2 times root 2 is 2, times the 2 on the outside is going to be 4. For the radical there, we are doing the square root of 4 minus root 10 times the square root of 2. And when you're multiplying two square roots together, you're multiplying the insides. So the inside is 4 minus root 10 times the other inside of 2. That's all occurring inside a big square root. So we're going to get the negative square root of 8 minus 2 root 10. And that's as far as we're able to go. There are formulas behind taking the square root out of inside a square root like this when it's part of an expression. It's not really a necessary formula, so we're not going to really go into it and explore what that would actually kind of create. That's not necessary. We can leave it in this format right here, and that's perfectly fine. So just make sure you're careful with the manipulation of the different angles as you're doing that kind of thing. Okay, so for our last example here, we are trying to find the tangent's half angle. We're given secant is negative 3 over root 7. We're told theta is between 3 pi and 7 pi over 2, which means it's equivalent to being in between pi and 3 pi over 2, so theta is operating in quadrant 3. We don't need to worry about the half angle quadrant because for tangent, we're not going to use the plus or minus formula. I'm going to use the 1 minus cosine theta over sine theta. That way I can avoid having square roots inside square roots. I can avoid worrying about the plus or minus, and it's a little more straightforward for the problem. And again, I'm choosing that one over the other option because since sine theta is probably going to have a radical and so will cosine theta, I don't want to deal with the conjugate. I'd rather just deal with a single rationalizing problem there. So I need to get cosine and sine. Well, cosine is just the reciprocal of secant, so it's negative root 7 over 3. And then sine squared is 1 minus cosine squared. So we get 1 minus 7 ninths, which is 2 ninths, and then square rooting that gives us sine theta to be a root 2 over 3. And again, because theta is operating in quadrant 3, it's a negative root 2 over 3. Now that I have both the sine and the cosine values, I plug into our tangent theta over 2 formula. Tangent theta over 2 is our 1 minus cosine, negative root 7 over 3, over sine, negative root 2 over 3. So the double negative means we have 1 plus root 7 over 3 over negative root 2 over 3. And I multiply top and bottom by 3 because I have a complex fraction. Again, whenever I'm dealing with complex fractions and square roots in the same problem, I'm going to deal with the complex fraction first, and then I'm going to rationalize second. So multiplying by 3 gives us 3 plus root 7 all over negative root 2. Which I'm then going to multiply by the root 2 to deal with the fact that I've got a radical in the denominator. That gives us a 3 root 2 plus root 14 all over negative 2. And that's as far as the answer can go. Both root 2 and root 14 cannot be simplified further, so I can't write it any further. If we had a situation where instead of being root 7, let's say that was like a root 10 right there. Root 10 times root 2 would make root 20, which can reduce further, so you would have to simplify it there. So do watch out for problems of this nature that might occur. All right, so that's it for our half angles. We only have one topic left in Unit 7. That's going to be our product sum products, then general our product angles, and we'll talk about that in our last video. I'll see you next time.